So, ladies and gentlemen, let's just get started, okay? Okay. Ladies and gentlemen, good afternoon. On this panel, we have the topic as developments in aircraft navigation systems. I am Yang Honghai, Deputy Director General of Flight Standards Department of CAAC. We have 6 panelists now. I would like to ask each one of you to introduce yourself. Okay, we start from Luke.
Everyone, my name is Luc Tidgat. I'm from EASA. I'm Director for Safety Management and Strategy.
Good afternoon. I'm Tu Weijun, Director of Flight Operation Management Division, Flight Standards Department, CAAC. I've been in CAAC for 5 years, now in charge of new technology and aviation management.
I am Didier Poisson. I am manager of the Flight Certification and Operation Department in Thales, and I'm also test pilot for Thales.
Good afternoon. I'm Huang Liqiu, Deputy Senior Manager of Flight Dynamic Monitoring Office of Air China. I'm in charge of monitoring of navigation.
My name is Jean-Michel Roy. I am a test pilot with Airbus, and I had the great privilege 20 years ago to bring the first Airbus fly-by-wire in China and to introduce them in very famous airlines in China.
Good afternoon. My name is Bai Xiao, Senior Manager of Operations Management Department of China Eastern. So thank you for your introduction. Welcome to present in our panelist discussion. So the theme of this panel is developments in aircraft navigation system. As the moderator, actually, I know much better about China's situation, and I'm going to brief you some new technologies in China, and later on, Luke will introduce you the situation in Europe. So this is the big background. So, according to ICAO, it is promoting science and technology to promote safety and navigation insurance. As we all know, with the development of a new round of science and technology, we have the new version of revolution of science and technology. And it has been a major trend that we use new technology to replace traditional technology. In 2013, ICAO issued the plan of GANP, this plan from 2013 to 2028. And this is one of our strategies to improve sustainable capability of navigation. And this has been one of our guidelines of the improvement. And also we have ASBU. This is the concept issued by ICAO. This is a new edition of the technology and system of navigation to upgrade of our technology worldwide. Also, in the Appendix 6 of ICAO, there have been 6 requirement, actually compulsory requirement for international navigation, aviation industry. In the same way, EASA is promoting CAAC-EASA, system the Single European Sky ATM research. We noticed from morning session that EASA DG also is working on CAAC-EASA. He's in charge of this program. Later on, I believe Luke will introduce more details in this respect. CAAC has been improving the new technology. CAAC has this new technology application and development committee, which was founded in 2014, and it has been evolving and developing. We have our PBN implementation roadmap, which was issued in 2009. We have been using it and upgrading it for 8 to 9 years. And the goal, the major goals in this PBN have been mostly realized. And also in the year of 2012, the aircraft tracking implementation roadmap had been drafted, and our HUD implementation roadmap was issued in 2015. And very recently, we have also another version of HUD implementation roadmap, which will be issued very soon. And so this is the big picture. Now I'm going to introduce you HUD. In new technologies, among all the new technologies, we have a lot to say, but we selected HUD as one of the important examples to illustrate. So what is HUD, Hud Up Display? This is actually a very old technology in the field of military using. But recently, why it has been a heated discussion topic, because recently a lot of civil aircrafts are now adopting HUD technology. And this technology will fundamentally change the habit and behavior of our pilots and the training of pilots. So this is a fundamental revolution from traditional conventional display to HUD, and there will be a lot of changes in the process. So this is the CAAC HUD implementation roadmap. There is a timeline for our roadmap. So we have finished the most part of short-term plan. And for our midterm plan, the deadline is until 2020. And 50% of the fleet will realize HUD display. For a long-term plan, we hope to have 100% coverage of our all fleet of HUD. For my understanding, when we started to talk about the plan, the long-term plan, nobody believed us. So we divided it into 3 steps or 3 phases. As we can see, we have already finished the most part of short-term goals, and it has been achieved 100%. And now we're doing the midterm. Of course, this plan needs the support of manufacturers, OEMs. So we'll see how much or where we can go. About ADS-B, this is another technology. And this is a way of monitoring. This is one of the ways to monitor. The ADS-B roadmap is actually improving or promoting worldwide. The best part is Australia. In 2013, it was compulsory to cover ADS-B. But at the same time, two major aviation places, the United States, 2020. For Europe, 2016 for new aircrafts. Revised ones should be 2020. So its coverage is a little bit later. And China's coverage is, the plan is very close to the Americas. So this is a ADS-B out requirement. As we can see, for ADS-B coverage, we don't have a kind of consistent or uniformed roadmap worldwide. So my understanding is that it's developing. Tomorrow morning, and there will be the first ADS-B in pilot study in Hongqiao Airport, which is very close to this conference hall. We hope to start our program with all these trials. So we'll carry out the pilot tomorrow morning, early tomorrow morning at 5:30. In 2015, we had a revision of our roadmap. Why did we have to carry out the revision? Because we thought it was a little bit outdated and lagging behind the world process. So we revised our roadmap. So now in this new edition, we have all the plans for CAAC. We are thinking whether it is possible for CAAC to set up a new plan. We plan to have the decision or the fundamental roadmap in the latter half of this year. And we have several phases of our implementation plan. So the first phase is up until by 2017. The second phase is by 2020. Up until 2020, ADS-B out will have full operation. And the third phase is by 2025. Will improve ADS-B out initial and initial ADS-B in. This chart shows us the ADS-B coverage at 8,400 meter level. According to CAAC implementation roadmap, up until the end of this year, CAAC will have been finishing all the coverage. There will be 310 stations, and we will finish all the data centers up until the first half of next year. And we'll have the compulsory setup of ADS-B. Currently, it's basically the coverage of civil aviations, civil aircrafts. And it will be relevant to the Beidou navigation system. The last technology is about aircraft tracking. As we all know, the concept of tracking, the background is basically the story of 370, the loss of 370. Up until now, we don't have final results of tracking. So after the accident of Malaysia Aviation 370, then we have been establishing this roadmap or plan of tracking system. So we have aircraft tracking normal operations, and then we have abnormal operations, and then later on we have autonomous distress tracking and retrieval of an ADR and CVR. ICAO also has its policies and standard requirements, but the detailed policies are actually still undergoing or under working out. So a lot of criteria have not been issued yet. For CAAC, we have finished normal tracking. We finished it by the end of last year. So for normal aircraft tracking policy, we have the compulsory decision that you have to realize this 4D per 15-second tracking, which is required. So this is meeting the demand of the ICAO requirement. And this is compulsory as one of the policies of CAAC, and it has been implemented now. This is a requirement for outside China, but in China we don't have this requirement. For domestic operation, we hope to monitor with the air management system regulation policies. For domestic monitoring, we have ATC services, which is based on ATSU. We have a three-step roadmap. So now we are on this step up until 2016. We have all the use of existing technologies. It has been finished. We use ACAS and ADS-B. We finished this phase. And the second phase is by 2020. We'll use ATSU and emerging technologies. For example, broadband, Swift broadband, data usage, and ATSU. Also space-based ADS-B, and also new systems like a Beidou system. The third phase is by 2025. We'll have independent IP technologies, and the major one is Beidou system. The second phase and also in the third phase, a lot of the major technologies are now undergoing at the same time or simultaneously. For new technologies, we think new technologies will have tremendous influence on the safety and operation of aviation industry. But also we have a lot of challenges, especially for policy making. We have to be very cautious. For example, about balance, we have to analyze the cost and benefits. So we have to work on all the costs and benefits and automation and human resources.
And the input in terms of human resources, for example, as well as other considerations that have to be taken on board. And secondly, it's about training. The training of pilots, of operational personnel, air traffic controllers. So these constitute a very important part of our work. Risk mitigation is actually has always been something that we pay special attention to, because all new technologies may bring about potential risks that we may not have been able to foresee. And that's why we'll be very prudent and careful. And besides, in terms of strategy and policy making, we also adopt a multi-step approach so that our policies, once made, are steady and consistent. And international cooperation, of course, is critically important because aviation is highly global. It's a global industry. And through international collaboration, our standards will be applicable all over the world, everywhere. Airworthiness, operation, certification, it's the same everywhere in the world. That's it from me. I'm happy to invite my panel members, colleagues, to share their views. Look, would you please come to the podium?
You have a very nice presentation, exhaustive presentation on the three candidate technologies. As it was mentioned, what I will be trying to do now is to give the perspective of the regulator regarding, in particular, the slides 21 just presented the challenges, and without having, in fact, prepare together the presentation. In fact, I will, in fact, match completely what was said a few seconds ago. And that shows that between the two regulators in China and in EU, we have the common understanding. But let me come back to that to explain how we consider, or should we consider as regulator, the introduction of new technologies. Yes, there are challenges. Introduction of new technologies is a challenge, and there are 6 elements you have to consider, and we will have to see, and I will try during my presentation to show you that those can be tackled, and we will look after that through the panel how the technology can match or not with those requirements. First, speaking about new technologies means that they are unknown in terms of risks. And when the risks are unknown, it's required from the regulator to go through validation, and that I will come back to that. Second point, introducing a new technology requires some change management. Means that we have maybe to change rules. It means that we might go through a new rule making. Third element to be considered is the potential overlap between the existing already deployed solutions and the new solutions which will be coming from the new technologies. At a certain stage, you might have at the same time 2 solutions or even more. That's a problem for the users. And the perspective of the regulator is to protect, to defend, of course, the interests of the users, how they should consider the solutions. Fourth, always, and we are in the ATM sector, CNS ATM sector, it has been a question since the beginning of the history of CNS ATM, is how can we coordinate the ground equipment with the airborne equipment? And you have seen with the presentation here, we have even a third dimension, the space-based dimension, space-based equipment that required also coordination. Next is we have multiple types of airspace users. When we want, an industry wants to promote a technology, it might be perfectly fitted for one category of user, which might be well equipped and prepared to adapt It's not the case for all. How will be tackled that? It's an issue. And last point, when the deployment has been decided, like we see in China with the implementation program, how the synchronization of the deployment should be orchestrated. What will be the role of the regulator to ensure that we don't have gaps in the coverage? So there are the elements you have to put on your screen when, as a regulator, when industry is pushing and proposing, and when users want to make use or not of them. So if we go now through the three candidate technologies, how that should be read. First, the complexity of the technology, what I was calling the unknown risks. For this, what is required and what we are doing on the EU side is to have, in fact, a large validation program. And in this case, what was mentioned, the CAAC program is the framework offered to industry to show what they would like to deploy. This framework is reducing the complexity of the demonstration because you put around the same table the different actors, and you have, in that case, a full-scale demonstration. That reducing the risks. But even the technology is highly sophisticated. You remember it has been mentioned many times today. We have entered into a new environment called a risk-based approach, performance-based approach. So the industry does not need to come with a full certification file. It has to come with a risk assessment of the new technologies to simplify the validation. And it's up to industry to demonstrate the mitigation measures which are recommended to respond to the risks industry will have identified on their own and not the regulator. So the responsibility, so that's another element to reduce the challenge for the deployment of the new technology. In that case, the three candidate technology presented here, they match perfectly with this. They are part of the CAAC program. They are perfectly fitted to make a risk assessment. Second point, change management. Do we need a new rule or not for the three of them? There again, we are, as I mentioned, in the performance-based approach. That means that we will not go through a full detailed rule or regulation. We will go for performance-based approach. In the aircraft tracking example in the EU, we decided to go for an implementation rule imposing the level of performance to be matched to perform the global tracking, but not to describe line by line, piece per piece, the system to be deployed to ensure aircraft tracking. So that's another way to get through simplification and to have a light, what we are calling a light rule, or even soft rule, means of compliance. That's what the regulator is now preferring to do. That is the condition to have a light rule-making process. The third thing, you remember I mentioned overlapping between existing technologies, which will stay for a while. Today, in the navigation sector, you still have NDB, VOR, DMEs in the European region, together with ILS, with sometimes even MLS, and I can continue the list. This is causing a problem of sometimes spectrum and interferences. There, the regulator will have to organize how the coexistence of the existing systems can match with the level of added value the new technology can bring on site. And for this, or reading now, if we can, for the Chinese case and the master planning organized here, for example, for the ADSB, is perfectly matching this problem, because in China we understand you don't have the problem we have in Europe, We have too many systems, when in China you are still starting the implementation of surveillance capabilities, communication and navigation systems. You are perfectly, if you want, ready to host quickly ADS-B type of technology. That is probably the best case. China is probably the best case, the best candidate to have a quick deployment of ADS-B. When in Europe, we'll have at the same time ADS-B and other systems like, for example, SSR solutions, and that is an issue. The point I was mentioning also before is the coordination between the airborne, the ground, and the space-based systems. So how to deal with that? Here again, if it was decided in China to go directly to a trajectory-based management solution, which is what is proposed in the global air navigation plan, you will immediately tackle the big problem of the airspace management, which we understood is in China a big challenge today. Airspace management linked to civil military coordination, linked to the need to have appropriate navigation aids and air traffic controls, is really in Europe, seen as we are, a major challenge. You are again in a capacity with the opening of new airports, capacity of deploying new technology. You could probably more easily than we are going to the trajectory-based management quicker than us. This is a major, very good news, I would say, for China, because you could be seen as very much a pioneer of what we are calling in CAAC the I4D solutions. The different categories of airspace users, that was another constraint for the regulator. Here again, with the candidate technologies, the beauty of their characteristics is to make use of, most of the time, of satellite-based solutions from end to end for all phases of flight. That is also something which is probably very attractive to convince all airspace users motivated or interested to invest in the system, because you don't have the fragmentation we have today in the conventional systems, and that is where probably we have some solution. And the same for airport. When I say all phases of flight, it's including airports. So that there are the 6 drivers or the 6 elements a regulator would need to consider when he tests to be consulted to authorize or not the deployment of the 3 technologies there. That will be the examination that will be done. If no, and I would like maybe to go in the art of the conference today and just echo what was said since this morning. How our masters this morning were calling friendship, partnership, how the cooperation between China, EU, between CAAC and EASA could give birth or could promote the deployment of the technologies. There we have probably the possibility with the partnership, EU-China partnership program to support this and to maybe help the 2 parties to cooperate to see how we could help the deployment of them. And that could be done through validation campaigns within or without the context of CASA. That remains to be discussed among ourselves. But that is certainly something we would like to propose for the EU-China partnership program in 2018. And you must know that yesterday we had the meeting of the steering committee of this program, EU-China partnership. We have the steering committee adopted the 2018 annual program where ATM ENS is very important. It has been mentioned this morning, and I want to repeat that. So we have the possibility there to really to spend time, energy, resources, dialogue, to study how we could, through our cooperation, help to deploy the new technologies. And China might be seen as a sort of forward-looking territory to help and to test with industry to see how benefits can gain. That's what I wanted to say from the regulator perspective.
Thank you very much, Luke, for your sharing. EASA in Europe has done a lot, including advanced technologies, state-of-the-art technologies that we can learn from, and we are ready to interact more with EASA. We're Our next speaker is going to be Mr. Tu, Madam Tu, Mr. Tu, to share with us his take on this issue. Dear colleagues, good afternoon. As Luke was talking about EDSP, the latest technology, perhaps this is something, a new technology that has been much talked about, and what progress has been made. So that will be the major part of my sharing. As the moderator alluded to, the development of a technology, new technology, would go far beyond our expectation. I suppose all of us feel strongly about that. In 2001, this guiding plan or implementation plan was released, how ADSB should be implemented or could be implemented. And at that time, there was the precondition that where this radar free. That means in 2010, that was also for the radar free or where monitoring couldn't work that well. So ADSB was seen as complementary. But you see, in only a couple of years' time, globally, the ADSB construction and implementation has been so active, as you heard from the moderator just now. You see, globally, all major countries and major regions have had mandatory implementation of ADSB. Plans and policies have been put in place. For example, in the United States, on January the 1st, 2020, be it transportation of the passengers or the cargoes, the capability has to be there. And in Europe, also, the implementation has been made mandatory. That's 2020. Canada, Australia, a couple of years ago, actually, there was already this mandatory use. And also in Hong Kong and South China Sea, ADSB has become mandatory. So you see, for transportation, be it the radar-free region or other areas, ADSB has been a major kind of direction for new technologies. That's something that I would like to share to begin with. Now, what is the situation in China? Let's take a look at it. we have been, I mean, CAAC has been pretty prompt in responding to that. As early as 2012, that implementation plan was already put in place. Originally, it was by 2020, ADSB would be built. And then in 2015, the year before last, in line with the new development, there was a major revision. That is, the deadline was further changed or revised. For example, by the end of this year, in some key areas, and you can find, you see, the ADSB, the major areas where ADSB seem to be more urgent. And then by 2020, as you heard from the moderator, with more stations and data centers put in place, the CAAC will provide the service. The mandatory date has not been decided, but by or after 2020, there would be a gradual implementation. But for ADSB, the technology is still developing.
So I'll elaborate more on this aspect. So you can look at this slide. This is our plan for ADSB carry-out implementation in China. It has very special geography in the eastern part and very flat and the coastal area, but the western part is mountainous and the sea level is very high. So the standard high area covers a large part of the west side of China. So it is very special in China for eastern part. Traditional coverage, ADSB is kind of complementary. The double summit coverage, which is to serve better of the monitoring. But for the western part, ADSB will be the major monitoring method, which will replace the traditional monitoring methods. So on this chart, we can see we have issued our ADSB coverage roadmap, and a lot of work has been done. ADSB is not only requiring the setup of the station, but also a lot of there's other settings, aircraft settings as well. We have the statistics. At the beginning of this year, we did a survey about the ADSB capability of CAAC. We have more than 3,000 aircraft which have the setup, the carriers, the carrying aircraft. 80% of the aircrafts have the ADSB out. So this figure is actually very surprising to ourselves as well, because a lot of numbers or figures are very old. So this is a new one. The main crafts type are like Airbus 320. Among all these main types of aircrafts, 80% of them have the coverage, and even more than that. Among main types of aircrafts, we have higher coverage of ADSB out. As high as 90%. So we can say that we have the capacity of implementing or total coverage of ADSB. So I should say that it is rapidly developing. maybe it's because of the fact that our aircrafts are relatively new, so it's easier for us to realize the coverage. And another point I want to highlight is that now we have a better understanding of the physical performance of ADS-B, and CAAC is now implementing and promoting the technology. But we are not saying that we'll meet the requirement. We have to consider the cost and benefit, the balance. Well, the technology is developing very rapidly, but we don't have a kind of fixed number, or we don't have a kind of confirmation of the future development. So we still have to do a lot of work. For example, for ADS-B, the management, operation, what is the role or the expansion of its role in the operation of navigation, and how much or how fast we can carry out the coverage. You may ask, we have 80% of coverage. Why do we still have to expand or revise some of the craft? The fact is that the answer is that we have DO 206A and B as our standards, but in the United States, DO 206A is outdated, and most of their receivers don't receive the data from DO 260. So we have to update all the setups in ADS-B because some of the equipment has been outdated. So still we have to update the old versions of ADS-B. So in this connection, we have to work together with EASA, with our manufacturers. We have to consider cost and benefit. Considering all the complexity, we have to work out our own policy of updating and coverage. Also, we will work out the roadmap and the schedule. We would like to learn from your best practice and the manufacturers as well, EASA, the manufacturers. We hope to have more communications and exchange with you so that we can borrow some of your best practice. Now we all know the importance of ADS-B. This technology is the foundation of future operation of 4D systems. So this is very important. We'll spare no efforts to do it, to promote it. Thank you. Thank you for your sharing, Mr. Tu, for your sharing about the technology of ADS-B and the promotion of it and some of our plan. Now, our next speaker, Mr. Didier Potion, your ideas of this question.
So, which one? Okay. Okay. So, Mr. Young, you were talking about the promotion that you do in CAAC with the Hud Up Display, and as a pilot, I cannot go against it because I'm very much convinced that the Hud Up Display is a very efficient tool for pilot and for safety. And as a Thales employee, I cannot go against it because I have to recall that the first Hud Up Display which has been certified on a transport aircraft. It was 45 years ago. It was a Thales head-up display on a very nice aircraft, a Dassault Mercure jetliner. And with the same principles already, which enhanced safety and which gave better efficiency in flight, thanks to flight path vector, thanks to energy queue, thanks to glide path reference line. And it was also at that time offering operational credits. So from time to time, we have evolved the head-up display, putting it on different aircraft types, and following the technological evolution. Nowadays, we are offering on every Airbus the head-up display of the latest technology, and with a large field of view. No, the other one. And all our head-up displays are capable of EVS to even further improve the pilot awareness and also to improve the operational credits. And at a later stage, we are working to put the synthetic vision system in addition to the VS in the head-up display. But not all aircraft are capable of receiving a head-up display because of the size of the cockpit, because of the design of the cockpit, and we are working on another product, which is a head-mounted display, and it's called, in Thales, it's called a Top Max, and it has the same characteristic as a head-up display, and it will allow pilots of business jet aircraft, of smaller cockpit size aircraft, and also on a helicopter to benefit of the trajectory flying and the 3D flying given by the head-up display symbology. And we are currently, since 2 years, performing flight test within Thales, and we are putting also EVS in addition to the flight symbology, and we are putting SVS, and this year we'll do flight test with EVS plus SVS with this equipment. This equipment is also giving more capability because it's displaying flight information or navigation information not only in the aircraft axis. So we are developing the 3D traffic, which is ADS-B information on a aircraft which is chosen by the crew, for example, and which will help the crew to have visual of an aircraft which is in the vicinity, and also it will be very, very good for situation awareness about aircraft surrounding the present aircraft. And we also are considering to put a 3D waypoint. Like you can see here, it's a cone. So at low altitude, we can put waypoint, and then the pilot looks and can see the waypoint around his aircraft. So what I wanted to say is, from 45 years ago, we were believing in the 3D flying because it helps the pilot to be efficient, and it improves safety, and we can gain operational credit. But head-up display, it would not be interesting to have a way of flying head-up and a different way of flying head-down. So in Thales, we are developing head-on display and of new technology, and all head-on displays would be able to have synthetic terrain, SVS, synthetic terrain vision system, and to put even head down the pilot in 3D, in 3D flying, and to have the same element of flying than the head up, which means the velocity vector, energy Q, and glide path reference line. And the pilot is immediately in 3D when he's flying head up and head down, which is a lot more easier than flying with a traditional ADI, attitude display indicator. And this synthetic terrain vision system, this SVS, we have finished the development, and it will be certified next month. All the flight certification flights with EASA has been performed on the ATR 600, and then this is the first commercial aircraft which will be certified with SVS head down. It was the case for business jet, and now we think it is a good time to introduce it in commercial airliners. The next step, of course, very similar to what we have. We are consistent with the head up. The next step will be to put SVS and EVS head down, and so the pilot will have a seamless way of flying head down and head up. And what is important in a country like China and also Asian country, where you have a traffic which is under a very high-speed development, you will have to train new pilots very quickly. And it is very difficult. I am pilot, I know. It is very difficult to fly with a classic instrument system. When you are flying 3D, you will gain a lot of time in training, and you will gain very quickly, the pilot will be more efficient. It is an easier way to fly an aircraft. It is safer, and it puts the pilot directly in 3 dimensions.
Thank you, Didier, for your sharing. So this product is very exciting. I think it will be very exciting for pilots, for the crew. We hope to see it as soon as possible in our aircraft. Okay, our next speaker, Miss Huang Liqiu, with Air China. Thank you, moderator. I'm going to share with you the aircraft tracking system. Malaysia 370, the accident of it cautioned the world of the safety of tracking, the requirements of tracking. Now we have the requirements of 4015. Air China are now also one of the companies and airlines who had the requirement or the system of tracking. And according to the requirement of authorities in China, after the accident, we upgraded our system of emergency system, and we improved our emergency plan. We have a large fleet and very complicated airlines. Now we gradually improved our framework. We have the organization of precise and risk-based, very innovative and bold tracking system. I'm going to introduce you this system of Air China in about precise tracing positioning. In 2011, China started, was among the airlines who could trace very precisely. For example, we have 1-second tracing updating system, and in China, and 5-second tracking updating system. And we realized the fuel tracking system and all the data of operation and navigation is real time. So all data is real time data. We set up the platform of monitoring system and tracking system. This system is very user-friendly, and our staff is informed of the system. It's very easy to use. For example, you click and you upload all the information to the internet. And the second part is about risk management.
A very small error could cause a huge threat to the safety of the airline. So how would it be possible to grasp any data, any information first time? That is a challenge. So the abnormal kind of information and the monitoring of such information, we have several types. When it's offline, the oil mileage and the waiting, the return flight, and the connection, the overtime. And through all these warning information, we're able to take preventive precautionary measures. The third aspect is about innovation. Technology innovation has always been on the top of our agenda. But it has to be significant or meaningful innovation. Innovation should start from the real need, so that we're able to address the issues that certainly occur in the process of the flight. Based on such considerations, the new technology and telecommunication technologies have been adopted to do a better job. We have been developing a system at Air China to guard against leaking of oil, as well as other scenarios, and also for turbulences, for example, so that information will be sent or delivered to the crew in a timely manner. We plan to adopt other measures to keep a closer monitoring mechanism so that there is an integrated platform. The monitoring and tracking is a long-term work. It's the lifeline of civil aviation, and it's also a necessary path for us to adopt to ensure safety. We hope to join hands with all of you so that we'll be doing a better job. Thank you very much. Thank you very much for the sharing from Ms. Huang at Air China. We hope that such experience will be inspiring to other companies and organizations. Next, let's invite Mr. Jean Roy from Airbus to share with us his experience.
we have to come back to a key figure which was given this morning by our keynote speakers, is that we are living in a world which is running very fast, very, very fast. In the world, we consider the traffic growth is to be doubled every 15 years. And nowhere but in China, we can really see that growth at such a level. But we should not forget what are our key objectives. And for us, the objectives are clearly safety, efficiency, and comfort. To reach these objectives, we consider that we live in a very complex environment with many players. Should it be ATC? Should it be airport, aircraft, crew, airlines? But we consider that human remains at the heart of this very complex system. And that's a very important question, because human could be considered as a risk or as an opportunity. This is a very philosophical question, but as we are talking about safety, everybody knows when an accident occurs, and quite often the pilot, the human, may have been a factor. But what about all the accidents, incidents, which did not happen thanks to human being? This has to remain part of our global picture. So, if we say that human has to remain at the heart of the system to get our objectives, altogether we have to look at the right balance. Balance between automation and balance between human. In the last, automation has been seen as a solution all the time. More and more automation. This is clear that automation helps to improve safety. But together, we should ask the question, sometimes, is automation not a risk by itself? When the operator, the pilots, does not fly so often because he relies so much on automation, are not we opening new risks, new windows of risk? This is a very important question. And I would like to give an example, which is flight director. For many years, pilot had to fly with available parameter, attitude, and of course, with aircraft weight, going from low weight to high weight, altitude, low altitude, high altitude, speed, low speed, high speed. It's becoming more and more difficult to fly basic attitude. So we have introduced flight directors to help the crew. The question is today, did not we create a kind of addiction to automation? The question is open. So we believe at Airbus that we have the possibility to bring in our cockpit new technology which is not only automation, but which is innovation. Monsieur Brégier this morning gave the example of runway overrun prevention system. This is a very good system which does not replace the pilot, but which helps the pilot to take good decisions, maybe to go around when its energy is too high. So we have to define tools to improve flight safety, which are not necessarily automation, but which can be very good help to decision-making process by the crew. Someone would say RUPS, someone could speak about airport navigation, someone could give example about giving graphical weather on board to help pilot understanding after long-haul operation what is the situation in terms of typhoons around the airport, for example, going beyond the weather radar. And of course, we have here with the head-up display a way to help the man to remain at the heart of the system to be safer. On this subject, I would like to explain a little bit that HUD can be a great help for landing. By giving approach stability and better understanding of the trajectory and energy, we believe it could be a strong device to fight against overrun. Not only overrun, but also underrun. Because if you look at the statistic of accidents, overrun is one reason, but underrun, that means people who are landing before the runway, not having the right trajectory or not having the right energy, is becoming a key subject. It is true also that when people are referring to the HUD, they could oppose automatic landing, for example, with manual landing. And it's true that probably there is a difference between Europe and China. For historical reasons, Europe has invested a lot in the past in very high quality ground-based system. We have CAT 2, CAT 3 airports almost everywhere in Europe. And it's good. So we have developed auto-land system to take the benefit of this ground infrastructure. We had long discussions with China. China has decided to go a different way and to promote head-up display, investing on airborne system more than on ground-based navigation device, but still granting benefits with lower minima to this airport, which are equipped with what I would say classic ground equipment, provided the airplane is making its approach with HUD equipment. So, yes, HUD is something that we are supporting. We want to deliver solution to the Chinese airlines on all our airplanes, like the A350, which is going to be introduced in China this year with hopefully Air China and maybe Sichuan Airlines as well. You have to know that already half of the A350 in operations are equipped with head-up display for the pleasure and the benefit of flight safety. So HUD is important. Why? Not only because you are looking outside, but also because we are now, and that's what Didier has explained, we are using new parameters to fly the aircraft. For the last 50 years, we have using pitch and thrust, simply because the technology was the only one available to provide pitch and thrust to the crew. Thanks to new technology, we can now provide trajectory and energy references. And these are the route on how to fly a HUD-equipped aircraft. So this is new, this is great, and we have decided at Airbus that it should be made available, as Didier said, not only head up, but also head down. And we have decided to modernize our primary flight display head down with the very same parameters as head up, which is to say the flight path vector, the energy chevron, the new shape for the flight director. This is new. We have started the certification with EASA, and the first airplane, the first certification should be with a 350 this year, and we plan to extend that to all the fleet in the next couple of years. This is very important because for Airbus, the family concept is key. Yes, we want to introduce innovation, but we know also that it is important to deliver solutions valid on all the fleet, from the 320 to the 380 to the 350. This is very important. So, at the end of my speech, I would like to insist on the role of man, human, in this system that we are developing together. To reach these targets of safety, efficiency, and comfort, we have to get on board well-trained people. I think these discussions we have about certification process are very important, but we should link human to this view and consider that the training of the operator is key. Monsieur Brégier said that this morning. This was our point number 2. It's absolutely important to educate, to train properly the workforce to operate the airplane to come. We need to have solutions in terms of quantity. He was giving the name of 500,000 pilots for the next 20 years, but also in terms of quality. And maybe we have to help this training by defining new ways to fly, to navigate, to communicate, to manage system, to manage mission, which could be simpler. Simpler because technology helps to make things simpler. If I want to be in level flight, it's simpler to put a flight path vector on the horizon than to know which pitch attitude I should fly, which depends on so many parameters. If I want to maintain my speed, it's very simple to put this energy chevron on my flight path vector, giving no acceleration, no deceleration, better than to know by heart complex tables of what should be my thrust depending on my weight, my temperature, and so on. So for Airbus, we consider that we have a duty in these 2 directions that Mr. Brégier has named this morning. Technology, that's our work. We need to develop new systems, more advanced, not only automated, but which can be good help for good decision making. And clearly, we have to facilitate the training of the workforce. Should they be ground mechanics or pilots? This is, I think, what everybody needs in order to get better safety, better efficiency, and better comfort for the benefits of all. Thank you. 谢谢。
谢谢这个饶米绍记者给我们分享。
Thank you very much for your sharing the one very important value and philosophical principle. We would like to hear from China Eastern what they have for us. Mr. Bai Xiao, the Senior Manager, Operations Management Department from China Eastern. Good afternoon. Michelle shared with us the HOD, so China Eastern will be sharing how HUD is being applied in China Eastern. China Eastern was the first one to use HUD in 320 because we came to realize the obvious advantages of HUD. For example, enhance the scenario awareness of the pilot, the lowering or making the flight more punctual. So China Eastern, in our use of HUD, we were the first to deploy HUD. But at the initial stage of using HUD, we came across challenges. For example, in the AFM manual, there was no specific kind of that description of the actual flight. So when we provide an annex or conduct annex, we were using we based our operations on the ASA communication document. So we hope that this will become part of our manual at China Eastern. Besides, in deploying HUD, we found that our pilots were not so motivated in using HUD because it actually changed the deeply familiar kind of performance for the pilot. But as the pilot becomes more familiar with the new technology, our pilots started to gradually get used to and now like the use of HUD. So 3 elements that I would like to touch upon. The first aspect is the HUD proportion at our aircrafts. As of 2016, China Eastern has 571 with 149 that HUD, 26.1%. We estimate that by the end of 2018, we will have a total number of 680 aircrafts, and 289 of them will have HUD, therefore 42.5%. And it's estimated that by 2020, our total number of aircrafts will reach 800. Those with HUD will have 440, thus raising the proportion to 53.8%.
It is also in line with our implementation roadmap. Now I'm going to introduce you HUD certification. For 320 series, we got the certification of A320 family in 2014, and in 2016 we got the special CAT-1 for A320 family, and we finished our pilot this year and last year, and then we got the certificates of A320 family of standard CAT-2. For Boeing 737 NG series, we got the certificate in 2016, in October of 2016. We plan to get the certificates of standard CAT, special CAT-1 and 2 this year and next year. For HUD Outlook, Terrace as specialist introduced us their new technologies for future. Now we know that Airbus is developing next generation VS system and CVS system, CVS technology, hybrid vision system for future technologies. Our management team and pilots are very much interested in all these new technologies. We hope that Airbus and Thales will finish their development of SVS technology so that we can upgrade our technology into EFVS and CVS equipment. Thank you. Thank you for your sharing. EASA and CAAC are supporting new technology implementation for China Eastern. And China Eastern is a very good, actually, case for us to provide data for our new technology. So it is our scheduled time to finish, but we are a little bit, we started a little bit later, so I still want to give you some opportunity to ask questions. So among our audience, do you have questions? Please raise your hand if you have questions. Okay, we have one of the audience here. Thank you. Thank you. To ask the first question, would you introduce yourself? I'm with China Eastern. I'm among the flight crew. I have 4 questions, actually. Question 1 to Mr. Luke. You talked about monitoring system and 6 dimensions. My question is that for regulation and monitoring, from the aspect of risk management, how can you balance the new technology, the instability of or uncertainty of new technology, and the safety how can you evaluate the risk of a new technology? This is my first question to Luke. My second question to Mr. Tu. ADSB is developing very fast in China. My question is that in terms of application, how when can we get to use it? We know that we have some pilot project, but in real application, we still use the traditional way. So when will we use it? My third question is to our captain. I'm very glad to hear that you have a different view of our other speakers. I'm very much interested in 3D flying. So in the future, for trials, now you realize a 3D display. In the future, for real practice, do you have any caution or training element for this for the usage? My fourth question is for Michel Roy. Jean-Michel Roy, you talked about management and technology. Human being or people are very important here. Yes, I agree with your philosophy, but how can you carry out the training system in the training and education system for pilots, for captains, whether it is more important to do management or to carry out technology for them? So which is more important, technology, profession, or management or administration level? So can we answer the questions one by one? I don't know whether you have taken down the notes.
First question, yes, it's a very interesting one. It's where the regulator will struggle with, as I mentioned, with the complexity of implementing a new technology. In fact, the response is the risk-based approach and the collection of data. What do we mean? That when a product will be put, before it's put on the market, there is a need for the manufacturing industry, the supplier, to put the system into context and to validate it and to submit data to the validation authority. And that the risk validation authority will assess if the risk assessment done by the supplier is at the level expected vis-à-vis the risks. The industry itself will have a list to be treated and to be mitigated. So in a nutshell, I mean, the responsibility is on industry to present the case and to convince the validation authority it is good for being commercialized and to be certified. And of course, it's not the classical certification process we had for the previous technology that would never work anymore. It's too complicated, it's always too late, and it's not appropriate since now through the collection of data, we have enough knowledge on how the system will work.
So let me answer the second question. So your question is very practical, and we are thinking about it every day, actually. ADSB, as a new technology, the fundamental goal is to improve the efficiency in practice. And the technology has to be in line with the practice. Like in LASA airline, in the real practice, we need the roadmap, we need the policy or the guideline in place as a criteria. So here we are thinking how can we combine the management and the operation and the usage of ADS-B. In the case of LASA airline, we had already realized the coverage, so the time span has been reduced from 10 seconds to 5 seconds. It is not only the management of a meter, but also the management of a procedure. One thing I want to add is that it is not right that you think as long as we have this meter or ADS-B system in place, you have everything to ensure the safety. Actually, in terms of operation, we have communication, navigation, GPS. ADS-B can provide us the monitoring, but also we have to have other supporting systems and data as well. In LASA airline, we still adopted the procedure management mechanism, but later on, with the ADS-B coverage, we hope that will narrow the time limit, the time length, and also narrow the gap. Narrow or reduce the time of updating and revision of the system versions. Now we are also coordinating with the authorities, and also we're talking with the relevant departments to issue more guidelines. So this is something that I want to add. Actually, based on this question, I want to talk about something more. After 2020, we'll have full coverage of ADS-B out, but we'll have ADS-B in. After 2020, we have more matured usage of ADS-B in. Tomorrow morning, we have the trial of VSA system demonstration, and also ITP system is a new version, and also the SUIF monitoring and CADVS based on TR. We have many other systems. Internationally speaking, we have new technologies, new systems. As for airlines, we hope that airlines should also be aware of all these updating new technologies or new systems ready in place. So hopefully all these airlines like China Eastern will have more coverage of not only ADS-B out, but also ADS-B in, and also other technologies and systems. Thank you. So DDA, Mr. DDA, the third question.
And specifically synthetic terrain system, there are many, we have to be very much cautious. There are many cautions when we develop it. And it is the work that we do with the aircraft designer and with the certification authority. And it will be too long to detail all the attention that we have to give. But what I want to say to explain you is, for example, for ATR, we had to do 12 different mock-up, which has been used in simulator, and also a third of them have been flown in flight test. And we have discussed from the beginning with EASA to ensure that the certification is well achieved. So in terms of design and development, there are many cautions. And we have also to be very cautious with the database, and we are providing the database, and we have a very strict way of controlling the database each time we import a new package. And but the database is also coming from a database that we know very well and that has flown from long time, because it is the terrain database of the toes, but which is a lot more precise. As you are crew member, as you are pilot, what we have seen in terms of caution for the head-up display is first to be in the good sitting position, because without head-up display, we see that the pilots are putting their seats too low, too far away from the cockpit, which is not good for flying when there is marginal weather conditions. And thanks to the head-up display, it forced the pilot, at least for takeoff and landing, to be in the good sitting position, the one which has been designed from the beginning of the design of the cockpit. Another caution is either for the head-up display and for the head-on display with the synthetic terrain is crosswind, because the display of the runway, synthetic runway, and the runway center line, when you have, let's say, 20 degrees of drift, is surprising for a pilot when he sees it for the first time. But which is very strange, because it is exactly what you see outside. So you have to train the pilot a little bit more on crosswind to demonstrate that what he is looking outside, what he's seeing outside, is identical to what is displayed head down. So it is one of the points you have to focus in the training.
那么第四个问题，我们请这个饶米少。
Fourth question, Mr. Jean-Michel Roy.
When I arrived in China, the situation 20 years ago was based on Russian aircraft, Russian-built aircraft. So at that time, the different tasks that were expected for the crew to fly, to navigate, to communicate, to manage system, and to manage mission were given to 5 different people. The pilot was flying, the navigator was navigating, the radio was communicating, the flight engineer was managing the systems, and maybe the leader was managing the mission. With innovation and with technology, we bring to you a new world with the A320, going from a 5-crew concept to a 2-crew concept, thanks to a lot of innovations which have been introduced. For example, navigation was facilitated with the flight management system. The management of the system was facilitated by the use of ACAM, Centralized Alert Monitoring System. We had then the problem of how to fly airplane, and we have been using a lot autopilot. But it's a fact that today there are 2 parts of the flight which cannot necessarily be flown with autopilot. Takeoff, there is no today autopilot taking off, and landing, as I told you earlier, not always automatic landing is possible. So the question, which was a philosophical question that I tried to raise, is the balance between automation that you have to monitor and manual skills when the automation is not there to do the job. We believe that head-up display is a great help because it allows you to use the very same display and monitor the automation when flying with AP on, and to hand fly looking at the very same parameters when making manual takeoff and or manual landing. So for me, this balance is key. It has to be defined by the pilot based on the condition, because not always the automation is better than the pilot and vice versa. And to facilitate this monitoring and or action by manual flying is for us performed through head-up display.
Thank you for your answering to these 4 questions. So, are there any other questions? So, would you introduce yourself first? I'm with Air China. My question is to Jean-Michel Roy. So, Captain, my question is to you as a pilot.
Of the Hud plus EVS, we all get benefit from that, and it not only improved the environmental awareness to the pilot, but also we can get additional advanced. For example, for the protect for the tail drag on the takeoff and protect long run from the landing. But the attitude of the to the heads-up display and the EVS is totally different from Europe and American. In the American side, all the companies, especially on the Boeing side companies, they all installed a large amount of heads-up displays, and they also reduced the minima by their rules. But the European side, a totally different story. Your attitude is not very positive. Although you have very good ground equipment, category 3 landing, but after landing, you must taxi out to the runways. Then you will rely more about the heads-up display and the EVS equipment. So my question is, do you have any roadmap of the Airbus aircraft to install the heads-up display and the EVS? Because in China, we have roadmap. In Boeing side, from the American and the Japanese carrier, they have the roadmap, and most of their aircraft have already installed this kind of equipment. But from European side, from the Airbus side, you know, from the China, we have nearly half aircraft belong to the Airbus. But the amount of the percentage of the head-up display are totally different stories from Boeing and Airbus. So do you have roadmap to that?
Well, that's a very good question you are asking. I think there are different layers to be considered. Number one, you say Boeing is sometimes ahead of us in the deployment of head-up display. This is true, and when we look at the figures which have been shown today, it's a fact. But maybe we can explain why. You have to remember there is a big difference between the 737 and the A320, because the A320 is basically capable of auto-land. It is basically capable of category 3 approaches. So in the countries like Europe, where Cat 3, Cat 2, Cat 3 is largely available, the existing architecture of the A320 was totally satisfying. That's why, by the way, we have had such a success of deploying our airplanes. We respect the fact that as now it's possible to get lower minima in China thanks to the HUD, and it is part of the HUD roadmap in China that we discussed with Captain Yang, we definitively want to deploy head-up display in China, provided, of course, our customers buy it, because we are still living in a commercial environment. So we are looking for our colleagues from the airline to buy it. As for us, it is an option. It is not basic, it is an option. So this is my first part about head-up display. The second part is about enhanced vision system. It is true that it is a technology which is new, which is largely distributed on business jets, but not yet largely distributed on large commercial airliner. If we put Federal Express aside, I think for the time being, not so many airlines have selected EVS. The question could be why? Maybe because today, still, the regulations have not aligned on the benefit that EVS can bring to a flight. It is true that the US FAA has recently delivered some key advantages to EVS with the so-called EFVS1, lowering the minimum down to 100 feet and even to 00 with this new full capability based on enhanced vision system. I think Airbus is monitoring that very carefully. In addition, we have been reminded by the CAAC that EVS is part of the CAAC roadmap. First, head-up display because it was priority number 1. Then EVS as the phase 3, if I understand well, of your roadmap. So yes, Airbus is committed to work and consider solutions on the EAVS requirements from the market. And we hope that EASA will support us by giving to the EVS-equipped aircraft similar advantages to what the FAA is doing. But that's another subject.
Let's continue with questions. See if there are other questions. We'll wrap up at 5:30. I don't know if the panelists here, if any of you would have any question. Do you have questions to ask each other?
It's not only a question, it's more a remark that I've been very, as you have understood from my speech, we are working on head-up display since a long time in Thales, and we believe in a head-up display. And I've been very impressed of how the CAAC has understood the benefit of this type of equipment. And it is also true for ADSB, because we are providing a DSB which is giving many advantages for the pilot for ADSB in with the ATSO function. And personally, I've flown with the ATSO function, and at the time of the certification of in-trail procedure for polar and oceanic region. And I've seen also that you are providing for visual separation approaches, and it is definitely a very good help to the pilot, which is not complicated, just to have an aircraft symbol, which is the preceding aircraft, just to have its ground speed and the precise distance. And it is a great help for the pilot. So I'm very impressed by the fact that you are going in the very good direction for those two innovations, which from my point of view should not be innovation and should be everywhere in the world. So congratulations for that.
Thank you, Diak, for your compliments. I have a question for Air China. Ms. Huang, you were talking about your monitoring system. For the three-step approach that Air China has been soliciting opinions or advice. So what's your take on this? Well, what is the second step? The second plan, let me take a look. The second step, second phase. I'm going to replay it. I'm sorry, the speaker is not speaking to the mic. Thank you. Can I have full screen? My question is on this. You see the second and the third step. The ATSU and emerging techs. In fact, Air China has been integrating the monitoring systems. So ADSC or others that I mentioned, the monitoring or turbulences, all such information will be integrated into a monitoring platform. And we do hope that for the second phase, we would hope that the regulators would be able to share information with us. As I said, the pre-warning of turbulences, if such information can be shared, I'm sure that will be hugely helpful for us. So that's what Air China has been doing, and also a suggestion. Thank you, Madam Huang. Well, CAAC hopes that we will receive prompt feedback from our businesses. Any other question from the audience, from the floor? There's one more question there.
Vivek Aaron from EASA, acting head of large airplanes department. It's not really a question. I received a kind of question from Captain Roy just a few minutes ago about the support that EASA could bring to Airbus and to the industry for giving credit, operational credit for EVS systems. And I just wanted to bring a kind of an insight of what we are doing currently. First of all, we've been working on EVS and operational credit on EVS on business airplanes for long. As you mentioned, business airplanes, HUD and EVS is not a novelty. It has been implemented for probably more than 10 years on business airplanes, and EASA took part to many proof of concept, sometimes together with the FAA. We faced different challenge than the FAA sometimes because of different regulatory framework, especially on the operational side, which does not enable us to provide the industry with exactly the same time frames, the same solutions. But still, we have some achievements on business airplanes. And now what we are doing currently is we are completely refounding the CS AO, so all-weather operations, whereby both on the operational side and the airworthiness side, we are defining much less prescriptive rules for determining minima, both on the decision height and runway visual range. And it's much more performance-based. So basically, according to the quality of the image, quality, accuracy, integrity of your system, you'll be given credits that are commensurate to the performance of your system. And this is a huge work that we have launched and that we are now performing together in collaboration and partnership with the industry, putting in the loop also other airworthiness authorities, and we hope to put that to complete the work in a timely manner within the next year. And provide the industry with the same, going the same direction than China, than the FAA, and even going further than that.
Thank you. On my side, I have just one question. One question maybe for you and for my colleague, because last time we met, we have heard that China Eastern was designated to be the leading airline on Airbus airplane to develop low visibility operation in China. And I understand that a test flight was supposed to happen maybe last week. So do you think it's possible to get some first feedback from the authority and or from the airline about this move again forward for China for low visibility operation?
I'm sorry, you are not speaking to the mic. Was it, which feedback do you want to get from CAAC? Or
Understand a flight test was performed last week by China Eastern on an A320 flying to Urumqi to experiment low visibility operation. And I wanted just to know if you had any feedback, if this flight has been successful, and if we were continuing in the good direction for the benefit of flight safety in China.
let me answer your question from a regulator's perspective, see if that is the feedback that you would like. China Eastern did this pilot, which was approved by CAAC, so, which means the door is now open. So China Eastern can continue to complete or to land on the airports with the proper equipment. Other airlines can do the same as long as all the conditions are met. The second feedback is a matter of approval. I suppose there are still challenges or issues. For Airbus, the description of the capabilities, because on a conventional sense, you have to first receive the approval. So the descriptions of the capabilities has to be either the flight manuals or the certificates that are provided by CAAC. That would have to be from EASA. But in EASA's system, we haven't been able to found for this category 2 or category 1, none of the descriptions that we have been able to find, which means that the regulatory contents and the regulations in Europe do not seem to match. So, I mean, by this move, this pilot is an excellent bridge. So I suppose that would require a specialized discussion between CAAC and EASA, because up till now, it's still a bit vague kind of feeling. That's my response to your question. I wonder if then let me talk from my perspective. Well, on April the 20th, the pilot was smooth from Hongqiao to Urumqi. We did this low visibility pilot and at Hongqiao Airport, and in Urumqi we used HUD to test the Cat 2 standard. and also simulated the low visibility procedures. I said this is smooth pilot operation. But let me put it this way. China Eastern has been the forerunner of using HUD. We have come across difficulties. For example, in December 2014, we already received approval of operating. But it was not until April the 20th we received the validation of CAT 2. So it was a relatively, a long process. But of course, for the validation itself, it's pretty smooth.
Congratulate you, China Eastern, the crew, the airplane, a little bit for us, and the CAAC for this move forward towards a common goal, which is to improve low visibility operations in China thanks to innovation and technology. So congratulations to all of you.
刚好我也想提一个问题啊，因为刚才我也介绍了，东航现在是全球首家在320系列飞机上获得了特殊2类运行批准的公司。那么我们想了解一下，欧洲或者是其他国家的航空公司，他们对于320飞机上或者说是单通道飞机上安装 HUD 设备是一个什么样的意愿，或者是有什么样的计划，或者他们的想法是什么样子的？
你这问题是在问谁？
泰雷兹或者是米歇尔都可以，就是谁了解谁回答嘛。
好。
Whoever has an answer for me, I would Michelle or. Yeah.
So from Thales. 行，那就是这个问题是泰勒。
So this question is who will be taking this question? Let me repeat my question. China Eastern is the first in getting approval. China Eastern is the first in getting the approval.
Special too.
I will repeat my question. China Eastern is now the first in getting this approval for operating HUD on 320. I would like to know if other airlines in other countries, the pilots, for example, European airlines or airlines in other countries, what are their plans for using HUD?
As I told you, if we take the latest Airbus product, which is the A350, today 50% of the fleet delivered is HUD equipped. So we have other operators like Singapore Airlines, like Ethiopian, like Cathay Pacific, who are HUD equipped. So the crew have been trained to learn how to use the HUD basically. Today, they are operating low visibility operations, but they are operating it based on the basic aircraft architecture, which means autopilot on, 1 or 2, down to Cat 2, Cat 3 minimum. So today, these operators, they don't get operational credit because of Hud Up Display. The case of China is different because you have opened a new door, not only giving credit for Cat 2, Cat 3 that we can fill easily with Autoland, but also offering on about 50 Chinese airports special authorization Cat 1. This today does not exist, as far as I know, anywhere in the world but in China. So we consider that your decision is a very good move. We had this workshop meeting 3 weeks ago all together in order to analyze the situation. We respect that our airplane is fully capable of, provided we give to the customers, the airlines, the good procedures and the good training. This is what we have started to do, and we at Airbus are committed to give a full package of procedures and training by the end of June this year. So we will support you 100%, but it is a fact that China, on this specific domain, is a leader in the world. You are the one leading the way to low minima for approach, thanks to Head Up Display on this SA Cat 1. I'm not talking about Cat 2, Cat 3, I repeat, we have Autoland and we have the solution, but for the special authorization Cat 1, you are very specific in the world. And again, I congratulate you for that vision, which is leading us to support you in this flight safety improvement.
因为时间呢。
Okay, so in the interest of time, we will have dinner at 60, so we have to wrap up. Thank you very much for your patience. We are way over time. And let's have a big applause to thank our panelists. Thank you very much for your sharing.